Hello, welcome to our next class. We are going to be learning about patterns and sequences. That is related to math specifically. I know you guys know what patterns are. The difference between the two, patterns can be shapes. So if you look at the top two examples, this design here on the left, that is a pattern. You've got blue circles, red circles. It's designed to make an art project. But patterns can also look like what you saw in elementary school, where you've got shapes repeated one after the other. Sequences is specifically to math, where you've got a series of numbers that goes on forever. And we're going to learn about two types, arithmetic sequences and geometric sequences, and we're going to talk about the difference in just a second. All right, take out your notes, page 43, and make sure you have a pencil so you are taking notes because I'm going to be checking. If you look at your top of your notes, you've got the two boxes. The first thing we're going to talk about is arithmetic sequences. That's this top box. Arithmetic sequences is just a fancy way of talking about a series of numbers that are formed by adding the same number to the previous number. And I want you to put a little note that this includes adding a negative. Because remember, we've just studied integers, so you're going to see integers coming into your patterns, your sequences. You're going to see it going into your order of operations, your substitution problems, all of those things. So make sure you know that that includes adding a negative number, which means you're technically subtracting. What we refer to that number that we're adding and subtracting each time, it is called the common difference. And I know difference means subtraction, but it's the number that we're using each time to write the next term in the sequence. So that is the number that you are adding to each term in an arithmetic, fancy word, arithmetic sequence. And what you need to know about these sequences is it's always the same number. So if it's an arithmetic sequence, that means I'm always adding the same number. So if you look at this example, I'm going from 1 to 3 to 5 to 7. Each time I'm doing that, I'm adding 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. I could go ahead and figure out all the numbers that continue to go on. The next number would be 9. The next number after that would be 11 because I'm adding 2 each time. Granted, they're not going to be that easy, but that's what we're looking at. If you have a sequence where the numbers go up by 1 and then they go up by 2, then they go up by 3, that's not an arithmetic sequence because you're not adding the same number. You don't have a common difference. It's not the same number that's being added each time. All right, the next one that we're doing is the geometric sequence. That is the fancy word for saying that we're going to have a series of numbers that's formed by multiplying the same number. Make sure you know that's the same number to the previous number. And with this one, just like we had adding a negative, this includes multiplying by negatives, but it also includes multiplying by a fraction, which is the same as dividing. Because if I multiply by 1/2, that's the same as dividing by 2. So that's what a geometric sequence is. Remember, it's the same number being multiplied each time. And this one, instead of having a common difference, we have what's called a common ratio because we're multiplying. So that is just a fancy way of saying the number that you are multiplying to each term in a geometric sequence. And if you notice over here, put little reminders. So arithmetic is plus or minus or adding a negative. Geometric is multiplying or dividing. Okay, look at the next little section. This is under those two boxes. So when I taught this before, it was with our functions unit. But another way to think of sequences like a function machine or a function. Oops, it helps if I use a pen. When we say a function machine, that's an input-output. So if something goes in, what number is going to come out? So that if we have that, the input, and when we get to functions, you'll understand this a little bit more. That's our x value. And then the output is our y value. So if you've been in science before and they've asked you about independent variables and dependent variables, your independent variables are your input. That's what you're doing, what you're putting in. And the dependent variables, what's changing or what comes out when you change something. So, and we'll come back and go through that at a later class. So if we look at our two examples here that we have on this page, the first one I know is arithmetic because I'm adding a positive number. So now we just have to look at this and say, what number am I adding? Well, if I go from 5 to 15, what am I doing there? What would I add to get to 15? Or think of it this way. 5 plus what number equals 15? And then 15 plus what number equals, and we don't know that one yet. And then that number plus what our common difference is equals 35. So let's think about how we're doing this. What do I add to get 15? I add 10. So if I add 10 to 15, I should get 25. I start at 25 because that's where I left off. Add 10 because this should be the same for all of them. 25 plus 10 is 35. So I put, or think of it this way, this is plus 10. This one would be plus 10. To go from here to here is plus 10. So this is 25 that gets filled in the blank here. And our common difference that we have is plus 10 because we're adding 10 each time. The expression, remember an expression is a number sentence with letters, numbers, but no equal sign. So we'd write a number plus our common difference, which is 10. And that's all we're going to write. So it's a number plus 10 is our sequence. So I could continue. This sequence can go on forever. So if I thought about my next one, what would the next part be? Do 35 plus 10. My next one would be 45. And I'd keep going up and up and up and up and never stop. I could do it till I'm 100 if I live that long. Okay, what happens if I add a negative number? Remember, adding a negative is the same as subtraction. So let's look at this. I started at 54. I'm adding a negative something, and I got 49. Then I started at 49, and I added that same number and got 44. Then I started at 44, added that same negative number, and got 39. Then if I'm at 39, I add that same number, and I get what I'm missing. So we have to figure out what that number is. The easiest way to do that, since I know it's a common difference, is to find the difference. What is 54 minus 49? Okay, I cannot subtract 9 from 4, so I'm going to borrow from the 5, make that a 4, make this 14. 14 minus 9 is 5. So each time I'm adding a negative 5. So if I look at this last one here, 39 plus a negative 5 I'm taking 5 away. That would be 34. And remember with math, we're always looking at patterns. So if you look at the pattern here, we go 54, 59, 44, 39, 34. My next number would be 29. So you can see that there's a pattern with the ones digit. Each time it's changing between a 4 and a 9 because we're subtracting 5. So we are adding, our common difference is adding a negative 5. And our expression would just simply be a number, n, plus a negative 5. You could also write it as n minus 5 because that way we take care of those double signs. All right. The next part is looking at the geometric. So remember, these are geometric sequences. The other ones are arithmetic. These are geometric, which means I'm multiplying or dividing for these. So this one I'm multiplying by a negative number. So let's look. If I start at 1, I'm multiplying by a negative something, and I get negative 5. Then I'm at negative 5, I multiply by that same negative number, and I get a positive 25. Then I start at 25, and I multiply by a negative number and get a negative 125. And then I started at negative 125, multiply by that negative number, and I get a positive, I'll give it to you, it's 625. All right, what am I multiplying each time? Well, what times 1 gives me negative 5? That would simply be a negative 5. That's our identity property. So if it's negative 5 here, then it's got to be negative 5 for all of them. And let's make sure that works. Negative 5 times a negative 5 is a positive 25. That's correct. Positive 25 times a negative 5 is a negative 125. And lastly, negative 125 times a negative 5 is a positive 625. Okay. This is not a difference because we're in geometrics. This is a ratio. So we're asking, what are we multiplying by? We're multiplying by a negative 5. So there's a couple ways we can write our expression. We can write it as n times negative 5, but you're not really going to see that anywhere. You're going to see it in 7th grade written as a negative 5 times n. And remember, if we have a number and a letter right next to each other, that means multiplication. Okay, the next one is by a fraction, which remember also means division. So we're looking at this, and I'm going from 28 times something or divided by, and that gave me 14. And I am at 14, I multiply by the same thing, and I get 7. I'll give you that. Then I'm at 7, I multiply by the same thing, and I get 3.5. Okay, what am I multiplying each time or dividing by? If you look to go from 28 to 14, we know we're dividing because the numbers are getting smaller. And how do I do that? 28 divided by or multiplied by something equals 14. We're actually multiplying by 1/2 or dividing by 2. Because 14 is half of 28. So our ratio, our common ratio, is multiplying by 1/2 or dividing by 2. Because multiplying by 1/2 and dividing them into 2 sections is the same thing. So our expression, again, we can write it 2 different ways. We can write 1/2 times n, like that, or we could write it as n divided by 2. Or you could write it as n divided by 2 this way, but this is not really 7th grade anymore. That's more elementary school and 6th grade. Okay, so those are our notes. Those are how the process for doing it. Now let's look at some example problems of what you might see on your SOL. So looking at number 5, says which sequence follows the variable expression a number minus 13. So we know for this to be, it's arithmetic because I'm adding or subtracting. It's an arithmetic sequence, and so I'm looking for, if I'm subtracting 13, think smart. My numbers have to be going down, not up. So if you look at this one, I'm going from 13 to 26 to 52. My numbers are going up, so that one is definitely not going to work. The same thing here, 13, 26, 39, I'm adding 13 each time. That is not what I'm looking for. I'm looking for a subtraction. So would this one work where I've got 1,000, then 987, then 974? So let's look. If I have 1,000 and I subtract 13, let's borrow from our 10 and make a 9. Make that a 10, borrow from that one, and then we have 10 minus 3, 9 minus 1, and then we have a 987. So does this one match that second term? It does. Now don't assume that the first one's going to match, because if I looked and say it was adding 13, these are both the same, but the third number is very different. This one is the only one that works, so we know that's true. But if you were to look at other ones, then you need to know you have to go more than just one. Okay, so let's look at another example. So for this one, number 6, it says which sequence follows the variable expression a number x divided by 3 or multiplied by 1/3. So this is a number divided by 3. And that's a geometric because it's division, right? So if we look at the first example, am I dividing here? If I'm going from 2 to 6 to 18, I am not, because I'm going up. If I'm dividing, my numbers have to get smaller. So if we look at the second one, that's a possibility because I'm going from 297 to 198 to 99. The numbers are going down. We just have to see if it's division. The third one, is that one going to work? I'm going up again, so the answer is no. And so the last one, we just have to look. Now remember, with multiplication and division, if you look back at some of the examples we had, the numbers get really big. If you're multiplying, they get really big really fast because multiplication in and of itself makes the numbers multiply faster or get bigger faster. So if we look at this, look at the two examples. We have 297. So if we take 297 and we divide it by 3, 3 goes into 29 9 times. That's 27. Bring down. We subtract, we get 27 again. So that's 9. So it should be 99. So if we look at our two examples, this one's 198, this one's 99. So we know that our sequence 4 works. Normally they're not that easy, so don't assume that they're going to be that simple. You may have to go 2 or 3 terms in to figure that out. And this next one is the type you're going to see the most often. They're going to say, what is the 6th term of a what kind of sequence? If it's geometric, we know that means multiplying or dividing. So, and now this says the 6th term. Well, that means we're looking for you to extend the sequence out and tell us what it would be later on. Don't assume it's the next number because most of the time it is not. So this is my first term, 40 is my second term, third term is 20. So I need to go 4th term, 5th term, 6th term. So let's think about this. What am I doing or dividing by or multiplying by if my number is getting smaller? I know that's definitely division, but what am I dividing by? Well, if I'm going from 80 to 40, then to 20, it looks like I'm cutting it in half each time. So I'm going to take 80 divided by 2. That gives me 40. And then so on and so forth. So I know I'm dividing by 2. That's my common ratio. So if we take 20 and divide it by 2, half of 20 is 10. Half of 10 is 5. Half of 5 is 2.5. So my answer for this one would be 2.5. So be careful on these because it does say 6th term, not the next one. You have to know that you need to extend it out several terms. Okay, just a few more and then we're going to be done. All right, if you look at this one, Again, we're working with a geometric sequence, which means multiplying or dividing. If we look at this, we're looking for the 8th term. So let's count how many terms we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So I have to go out 2 more terms. And numbers are getting bigger, so would that mean multiplication or division? Hopefully you know that if the numbers are getting bigger, that means multiplication. Let's start where they're really little. And let's say, what are we multiplying by? To get from 3 to 9, I'm multiplying by 3. So each time, my common ratio is times 3. So we have to go from 729, and we have to multiply that times 3. 3 times 9 is 27, carry the 2. 2 times 3 is 6, plus 2 is 8. And then 3 times 7 is 21. Now I have to take that term and multiply it again times 3. 7 times 3 is 21, carry the 2. 3 times 8 is 24, add 2 more, it's 26. 3 times 1 is 3, plus 2 more is 5. And then 3 times 2 is 6. So my final answer is 6,561. So that would be my final answer. All right, this is another type of question you might see. The daily growth of a plant can be displayed in an arithmetic sequence. If it's arithmetic, we know that means adding or subtracting. And if a plant is growing, we know that that's probably going to be adding. So we're talking about daily growth. What would be the height of the plant on the 9th day? Well, if we look, here's 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, 8 days, 9 days. So I got to go that far out. Let's look at the beginning and see what we need to do to find out what the pattern is. What am I adding by or subtracting? The numbers are getting bigger, so I know I'm adding. To find out what the common difference is, I'm going to actually take these two numbers, 21 and 12, and subtract them. So 2, we can't subtract 2 from 1, so we got to borrow from the 2. 11 minus 2 is 9. So each time I'm adding 9. Does that make sense? I know I added 9 here. 21 plus 9 gives me 30. 30 plus 9 gives me 39. 39 plus 9 gives me, 48. 48 plus 9 gives me 57. 57 plus 9 gives me 66. 66 plus 9 gives me 75. 75 plus 9 gives me 84. So what's the height on the 9th day? It would be 84 centimeters, inches, whatever it is. It didn't tell us. And then what was the common difference? We are adding 9 each time. Okay, that is basically what we're doing in a nutshell. You're looking at the types of sequences. You have to know arithmetic versus geometric, which one's adding, which one's multiplying. And you also have to know how to find the common difference or ratio, which is the number that's being added or multiplied each time. And you have to know how to extend the sequence. That's the only 3 things that you have to know with this. So I'll put a very, very, very short patterns and sequence up on Edmodo in just a minute. I do want you guys going back reviewing some of the old videos to study for your Unit 1 test. Remember, your Unit 1 test is coming up on Tuesday. Have a good evening and get out and get some sunshine because it's nice outside.